Hi everyone, and welcome to a little index law practice question overview. So these are some of the questions that we started working on the other day. They're from our Cambridge textbook and chapter 13a. So it's just the basic index laws, no fractional indices and no scientific notation. Let's just have a bit of a work through the questions that I've been asked about so far. So starting with 8a. The trick with any of these questions where you have large numbers in the base is to change those large numbers down to their primes. So 36 is 4 times by 9. So that's 2 squared times by 3 squared. And 12 is 3 times by 4. So that's 2 squared times by 3. And the powers will stay the same. Now all we have to do is we've just got bases and we've got powers. So we've got a power of power law going on. We expand out each of the brackets. And now we collect the like terms. So the bases of 2, I've got 2n and negative 4n. So if we bring those together, that's negative 2n left over. And if you have a look at the 3s, base 3s, you've got 2n and negative 2n. They actually cancel out. So we're just left with 2 to the negative 2n. And if we were to tidy that up, that's going to be 1 over 2 to the 2n. Awesome. Next one, it's exactly the same thing. Big numbers, turn them into their prime bases. Okay, so 5, that's already in its prime as small as it can go. 10 is 2 and 5. 8 is 2 to the 3. And 5 is as small as it can go. Now we just expand out those powers. And we collect the like terms. So the 5's on the top. Now we bring the 2's together and the 5's together. So you have 2 to the n on the top and 2 to the 3n on the bottom. That leaves me with 2 to the 2n on the bottom and the 5 to the 3n on the top and a 1n on the bottom. So that's 5 to the 2n on the top. Now that's a correct response. However, you can actually simplify that because they have exactly the same powers. You can only do this because they've got the same powers. You can actually factorize that power out. That's also correct. So either of those would be fine. Okay, the next one. The negatives are the things that are going to throw us out. So when we're working with negatives and powers, I almost think about the negative as being like a separate number. So I have to put the power on the negative as well. So we've got a negative number with an even power. A negative number with an even power is always going to equal a positive number. So I'm expanding the brackets here. So that negative becomes a positive. Then you've got 3 to the 2, x to the 4, y to the 6. I'll just continue on here. Now I'm going to change that 4 there and make that 2 squared, just so I can work with my 2's all together. Now top with top, bottom with bottom. 2 to the 2, 3 Okay, now we just cancel everything out. So let's have a look at those 2's. We've got a 2 to the 2 and a 2 to the 3. So we've got 2 to the 1 on the bottom, 3 squared on the top, x squared on the top, and y to the 3 on the top. There we go. Now these next two, we have to be ultra careful with these because we've actually got expressions in the powers as well. So you can make little errors. So when I've got expressions in the powers, I actually always do the full steps just so so that I make sure that I'm not losing any steps along the way. I'm not making silly little errors by missing something out. So I'm actually going to, if I look at the top and the bottom, there's nothing that I can cancel there already. So all I'm going to do is I'm going to start this division straight away. And now, when I have a very simple question, I would do division by just cancelling. That's a lot harder when you have expressions in the powers. So instead of cancelling, I'm going to do the full subtraction like the index law says. So I do the first power and then I minus the second power. Now, notice I've put a bracket. I always put a bracket around the second power because that reminds me that in the next step, I need to expand that negative across the whole thing. I need to subtract the whole second power. Now, I'm going to do the same thing with B and C. Okay. Now, we expand out all those negatives. And once again, I don't skip steps for this. I show all my steps just so that I don't lose anything along the way. And all I have to do now is tidy up those powers. So 2n and negative 2n, we get left with n. Negative 1 plus 3, that's positive 2. That's the A done. Now we look at the B. 3 minus 2 is 1 plus n. Awesome. Now let's have a look at this C. Negative 1 minus 2, that's negative 1. I'm going to put that behind just so it's a bit tidier. Negative 1 plus 2, that's 1n. There we go. Easy. Okay, this last one can be a little bit tricky. There's actually a couple of ways you can do this last one. So I'll show you the first way that I would see it. And just because of the way it works out, you can actually do it in a slightly quicker way as well. But that's only just in this particular case. First of all, simplify all of the bases. I'm going to change the 9 to a 3. And I'm going to change the 27 to a 3 as well. Now expand out all of those powers. Remember when you're expanding out that you need to expand out over everything. Now, let's tidy up that top. So let's have a look here. You've got an n and a 2n, that's 3n, and a negative 2 and a 2, that's 0. So we just get left with 3 to the 3n, and then we have 3 to the 3n minus 3 on the top. Now I'm going to show you the full method, and then I'm going to show you a little trick that you could take off on this particular question. Okay, so the full method is just like we did with 11e. So we go 3 to the 3n, and then we're going to subtract the second power, putting it all in a bracket, 3n minus 3. So we expand out that negative. So we get 3n minus 3n plus 3. The 3n's cancel, and I get left with 3 to the 3, which is 27. Now, in this particular case, we can actually have a little offshoot instead if we wanted to, and we could see that I can actually cancel the 3n's here, which would leave a factor of 1 on the top and 3 to the negative 3 on the bottom. Now to get rid of the negative power, we bring it to the top, so you get left with 3 to the 3, which is 27. So in this particular case, there is a shortcut, but some questions you won't be able to make that shortcut. Okay, I hope that helped. Thank you. Bye.